I'm going to update on the DNA Data Storage Alliance. My name is Dave Landsman. I'm one of the co-chairs of the Alliance. So let's go to the next slide after this. So first, a little bit of 2023 in review. So just to recap our mission, the DNA Data Storage Alliance, we were formed in 2020. We joined SNIA in 2022 as a technology affiliate. Our mission is to create and promote an interoperable ecosystem based on DNA data storage, or DNA as a storage medium. We have three main scope. Our scope has three main prongs: to educate the market and create awareness of DNA data storage, develop an industry technology roadmap around DNA so we can drive R&D and funding, because this is still very much a nascent area, and develop standards and specifications as needed by the ecosystem as it evolves. So next slide, please. Today, the organization, we have about 40 members. The board currently consists of five member companies: Twist, Western Digital, Quantum, Catalog, and Microsoft. Quantum and Catalog joined this year. We had a number of new general members join this year, and they're shown. So anyway, we're hovering right around 40. We've lost a couple, new ones join, steady around 40. We have four work groups today, which I'll talk about a little bit more in the next slides. And we just opened a new work group on standard codecs. We joined SNIA to help become a stable organization, and we've now got a solid financial base with our dues, and we were able to lower our dues a bit for 2024, and so we don't spend a ton of money, but we're in good shape. We have a social media presence on LinkedIn, Twitter, and we have a newsletter that we publish through SNIA. The events in 2023, or the main events that we did, where we had a face-to-face all-member meetup. This was just kind of like a working, twig, working sessions and informative sessions. Another event we participated in was the Molecular Information Storage Technology Workshop. This is sponsored by a government organization called IARPA. And the Alliance submitted a summary of the DNA ecosystem and made various recommendations on research and programs. And we participated in the workshop with a lot of other companies, many of whom were in the Alliance as well. And then STC had an archival and DNA data storage track, where once again we had 4 or 5, maybe 6 talks on DNA data storage. A cool little tidbit out of this is the folks at the Library of Congress, who do an archival storage event every year, saw some of these talks, and they invited us to present at their 2024 workshop. So I'll talk about that in a minute. So next slide. In the work groups, so we have a SIG, which is working on the industry technology roadmap. This is quite a big effort. It involves many sub-teams for the many chapters of the roadmap. It's over a year plus effort now. We think we're targeting to try and have it out by mid-year of this year. All the core roadmap chapters are drafted, and we're kind of getting into assembling the final document and pulling it together. As an outgrowth of the technology roadmap, it was our submission to MIST too. And we also wrote a chapter for the 2023 IEEE mass storage roadmap, a chapter on DNA data storage. We added, it's kind of a Cliff Notes version where it's not nearly as comprehensive as what our roadmap will be, but it summarized the state of the ecosystem. The DNA twig, we've had 3 working groups, and The Rosetta Stone group was basically defining what we call a master boot record. It's a way to find your way into a DNA database with a standard codec and be able to understand what's in the rest of the database, how was the rest of the database created, what kinds of structures are in the database or things that you need to know about so that it can be decoded. So we wanted to have a standard for this so that even if there are proprietary aspects of the main archive and the main database, you could at least in a standard way open up a DNA database. So this was our first spec. It was a big accomplishment for us. We just published the Sector 0 and Sector 1 specs on this. They're on the SNIA website now. And so this was very exciting for the Alliance. The data retention work group has been working on trying to create a standard accelerated wear method so that and a metric for half-life so that when different vendors promote different ways to store data in DNA, so their containment systems are all different, we wanted to have kind of a way to do apples to apples comparison. So we're working on a DNA data stability evaluation method spec. And that's ongoing, hard work. We're making good progress now, but we're hoping again to have this one done probably. Yeah, I won't say. I've made too many promises already, but we're making good progress. And then the third working group is interoperable interfaces, where we're trying to define a framework, basically a system level framework for what kinds of interactions and things between the stages of the DNA pipeline have to be accommodated to have an actual DNA data storage system in a data center. And this is also starting. It was kind of the third one to get started, and it's coming along. Next slide, please. Okay, so for 2024, our main goal is to finish the specs that we've started, and we're also starting to work on an open source codec, again, to try and have a kind of lowest common denominator or a standard DNA codec that people can use and make it open source. We've got a number of events planned so far. We're presenting at the Storage Technology Showcase, which is an archival storage, a kind of smallish archival storage conference, but very good, end users, things like that. So we're going to present an overview and we're going to do a roadmap sneak peek. That's in March. I already mentioned the Library of Congress event. They invited us to present our data stability evaluation method. There's a IEEE conference in July, and we're cooperating with Technion University and Technical University of Munich to do a DNA data coding theory and algorithms for DNA-based data storage. So that's underway. We're trying to get all the talks lined up, etc. And we'll be part of an archival storage track at SNIA SDC. Okay, let's keep going. The other thing in 2024, the main another big deliverable for us is we're going to try and create an archival storage initiative within SNIA, and this would accommodate not just DNA but archival storage in general. And this is because we know we want to create an ecosystem and a community. And DNA data storage by itself is a small and nascent ecosystem. So we're trying to put a little bigger umbrella around things. And the Alliance, this will be done with the Alliance, not solely by the Alliance. So this will be probably a separately created initiative that folks in SNIA will hear about in the coming months. And we want to do another in-person meeting. So that's kind of the snapshot of 2024. Okay, next slide, please. So why should you get involved? This is the first Alliance uh, focused entirely on DNA data storage. It's shaping a new ecosystem while the ecosystem is being built. So we think, the storage hierarchy in general needs a new layer for very high scale archival storage. And that's what, molecular storage is one of the possible solutions for this. So that's the relevance of the segment. It's really cool, really exciting. If people want to get interested, it's a highly interdisciplinary field. And we need experts, we need coding theorists, we need chemists, we need, all kinds of people, nanofluidics. It's a really interesting area of technology. So the contacts are listed there, um, and our dues are listed there. Those are just for reference, really. So next slide.